All right, you guys, I'm going to go ahead and get started here. I am Ronnie. I'm the outreach coordinator for AACD. Thank you guys for joining us for this session 6 of our ArcGIS Pro virtual training series. You guys can all hear me, right? Anyone
Yes, we
say yes?
can.
Perfect. All right, so I'm excited to have you
Yep.
guys all here today to share our agenda as we continue building on what we've learned in previous sessions. These trainings are shaped by you. And your questions, comments, and suggestions help us design sessions that are special, that are practical, relevant, and responsive to your needs. So we truly appreciate your participation, both during the session and in the feedback forms that we send afterward. Before we dive in here, this session is being recorded. There's a few housekeeping notes. If you need to step away or want to review anything later, you'll have access to both the recording and a corresponding reference sheet, which will be uploaded to the AACD website. If you've missed any previous sessions, those are available there as well, along with their downloadable reference sheets, which are linked in each video description. And the link is posted for you in the chat, so you have access to that. Feel free to keep your camera on or off, whichever you're most comfortable with. To minimize background noise, though, we do ask that you keep your microphone muted unless you are asking a question. And we'll be moving at a steady pace today to make the most of our hour together, but please don't hesitate to ask if you need us to slow down or revisit a concept. This training is for you, and we want to ensure you leave feeling confident from here. You're welcome to go ahead and post any questions in the chat at any time or raise your hand using the reactions toolbar. I'll be checking regularly and I'll pause so we can address your questions as we go. And then there will also be an open Q&A session at the end. So after the training, you'll receive a brief feedback form via email. It only takes a couple of minutes to complete, and it's one of the best ways you guys can help us tailor these sessions to your needs in the future. All righty. Let's see. So for today's session, we'll be focusing on transitioning from ArcMap to ArcGIS Pro, including a spatial reference overview, what spatial references are, how to check them, and how to transform them between different references. We'll also cover measuring the elevations, which we know has been a frequent topic of interest. With that being said, we'll go ahead and get started. I'm going to go ahead and hand things over to our speaker, Sarah James, to kind of guide us through today's session. All right, Sarah, you can go ahead.
Thank you. Um, so ArcMap to ArcGIS Pro. I know this has been kind of a big topic that we all have had to learn to love ArcGIS Pro, even if you didn't want to, because it's what we have now, which I like, but was a hard transition for a lot. So with that, that doesn't mean that all of our work in ArcMap is gone and lost forever, like I know some of us maybe thought. So if you have an old ArcMap, I did not have an old ArcMap. So I was able, Esri has a downloadable one that you can practice with if you want to try it out, or if you're worried about messing up one of your current ArcMaps that you don't want to let go. They have this kind of standard one that you can grab. And so the important thing is that when you're importing these maps into ArcGIS Pro, you kind of have all that data there. So that's the geodatabase, any shape files, and where they're pulled. Like you want them still in their same files, otherwise they'll come in broken, just like they would in ArcMap if the system doesn't know where to pull them. And then you're also looking to have this .mxd file. So this .mxd file is the actual like map, and then the geodatabase and all these shape files are, as many of you may know, the data behind the map. And just kind of a recap of last time. So when you're I'm looking at these right now on File Explorer. And so a shape file is made up of all of these file types. There's 7 of them, if I recall correctly. And so we'll need all of that to get that shape file properly loaded in. And like I said, the geodatabase and the map itself. But with that, let me show you how to pull that into ArcGIS Pro. So in Arc Pro, A lot of times we'll have recent projects here. If we're making a new map, we'll go to map. But to import one, we're going to want to start without a template. And so what that's going to do is it's going to create us a map, but it doesn't have our normal mapping system here like they typically would. And instead, we're going to import a map. So if we come to insert and hit import map, then we can navigate to where we have that folder file saved. For me, I put it on my desktop to make it easy to find. And it's only going to let us pull in this .mxc, which is perfect. That's what we want to do. And go ahead and hit OK. And when it pulls this in, you're going to notice, so this is an actual like layout. So if you guys recall, this is our little layout icon. And so it's not necessarily a map that we can edit and do things with like we like to. However, if you look at this contents pane, we see our map symbol here. And so that means that it is tying it in. It's just not loaded up into this screen. And so in order to get that up, the easiest that I have found is having this catalog pane. And again, if you don't have these open, you can always search for them on the search bar, or you can load. There's multiple ways to navigate through Arc Pro. There's a lot of buttons everywhere, but you can also navigate to them and open them up. And if you come to maps and right click on it, you can then hit open. And that's going to pop this data frame into here. Now it looks blank. Don't panic. If we go ahead, I'm going to turn this layer on, and then I'm going to right click on it and hit zoom to layer. So it's just going to pull me to it because it doesn't know where exactly to look, or it may have been really small. And so that's how, and because all of those shape files are still in the game, we're tying it to our geo database with it all being kind of right there. All of these come in very cleanly. You can edit them. You can do everything to them just like you would a normal shapefile. If they didn't come in correctly, they would have an exclamation point, and you would just have to navigate. You'd have to right click, go to data, hit set data source, and then you'd be able to navigate to the correct folder that has that shapefile in to bring that information back in here. So much simpler than I would thought, but that's how you can get your Arc map folders into Arc Pro. Does anybody have any questions about that? Cool. Well, with that, so as we're going between different map files, I thought this would be a good place to talk about spatial references. However, I think we should start with the basics of what they are. What are they? What are we talking about when we say that? And so for that, Ronnie has actually created a great video for us to kind of explain the basics of it. And then I'll jump back into the map and go into how you look for them and how you do some more things with them.
Perfect. I'll go ahead and welcome, everyone. My name is Ronnie Hemsley, and I'm the Outreach Coordinator for the Arizona Association of Conservation Districts, or AACD. Thank you for joining me. In this presentation, we're going to explore the fundamentals of coordinate systems and map projections. We'll look at the difference between geographic coordinate systems and projected coordinate systems, break down how latitude and longitude work, touch on datums and projections, and see how all of those concepts come together in practical systems like UTM. By the end, you'll have a clear understanding of why choosing the right coordinate system, datum, and projection is so important in mapping and spatial analysis, and how these choices affect accuracy when working with geographic data. So let's begin with our first topic, the difference between geographic versus projected coordinate systems. We're comparing geographic coordinate systems, or GCS, with projected coordinate systems, or PCS. A geographic coordinate system measures location directly on the curved surface of the Earth. The measurements are based on latitude and longitude, and these can be expressed in different formats, such as degree, minutes, and seconds, or as decimal degrees and even radians. On the other hand, a projected coordinate system represents the Earth on a flat surface. With PCS, the units can be given in meters, feet, or inches. The important thing to keep in mind here is that when you flatten the Earth, distortions will always occur. These distortions can affect things like shape, area, distance, or direction, but they're minimized when working with very fine-scale maps. Now, let's take a closer look at the geographic coordinate system itself. Here we're working with latitude and longitude lines. Latitude lines, or parallels, run east to west with 0 degrees at the equator and extending up to 90 degrees north and south. Longitude lines, or meridians, run north to south starting at the prime meridian at 0 degrees and extending out to 180 degrees east and west. What's important to note is that the latitude and longitudes are angular measurements. They're measured from the center of the Earth to a specific point on its surface. Think of it like hands of a clock. These lines are numbered in degrees and minutes and seconds, giving us a precise way to locate any position on Earth. So, while the previous slide introduced us to differences between geographic and projected systems, this slide shows us the actual grid system we use to define locations globally. Looking more closely at how latitude and longitude are represented on the globe, latitude lines circle the Earth horizontally and measure distance north or south of the equator. Anything above the equator is in the northern hemisphere, and anything below is in the southern hemisphere. Longitude lines run vertically from pole to pole, measuring distance east or west to the prime meridian. Locations to the right or east of the prime meridian are in the eastern hemisphere, while those to the left or the west are in the western hemisphere. When we put latitude and longitude together, they not only give us precise coordinates, but also tell us which of the 4 hemispheres, northern, southern, eastern, or western, a location is in. This makes it easier to visualize where in the world that place is located. So, latitude and longitude from the grid system, while the hemispheres provide a bigger picture framework for dividing the globe. Here we see a clear breakdown of latitude and longitude. Latitude lines run east to west, circling the globe parallel to the equator. The equator itself is 0 degrees latitude, and we move north toward the North Pole or south towards the South Pole. The values increase up to 90 degrees. Longitude lines, on the other hand, run north to south, stretching from pole to pole. The starting point is the prime meridian at 0 degrees, which passes through Greenwich, England. From there, longitudes extend toward eastward and westward up to 180 degrees. Together, latitude and longitude create a global reference system. The grid allows us not only to measure distance from the equator or prime meridian, but also to describe exactly where any point lies, whether it's in the northern, southern, eastern, or western hemisphere. So this photo reinforces how latitude defines north and south positions, while longitude defines east to west positions, and both work together to give us a precise coordinate. Now that we've looked at latitude and longitude, we need to introduce another key concept, datums. A datum is essentially a reference model of the Earth's shape used to anchor our coordinate systems. Because the Earth isn't a perfect sphere, different datums have been developed over time to provide more accurate measurements in different regions. For example, NAD 27, based on the Clark 1866 spheroid, was commonly used in the US, Canada, Central America, and even parts of the Pacific Islands. Later, NAD 83, which uses the GRS 1980 spheroid, improved accuracy and became the standard for North America. Today, the most widely used datum is WGS 84. This is a global standard, and it's the one that all GPS systems are based on. So when your phone or GPS device gives you coordinates, it's referencing WGS 84. Understanding which datum is being used is critical because the same coordinates can actually point to slightly different places depending on the datum. This is why precision mapping always includes the datum reference. Now that we've looked at datums and coordinate systems, let's talk about projections. A projection is simply a way of taking the 3-dimensional surface of the Earth and representing it on a flat 2-dimensional surface. One way to picture this is like shining a light through a globe into a piece of paper. The outline of the contents and the grid lines are projected into a flat surface. This projection becomes the foundation of your map. But here's the key point. Whenever we flatten the Earth, we introduce distortions. Depending on the type of projection, you might preserve one property, like shape, area, or distance, but distort others. And this takes us right back to the idea we started with on the first slide. The difference between a geographic coordinate system, which works on the curved surface of the Earth, and a projected coordinate system, which works on a flat surface. Projections are the bridge that connects those two worlds. Here we're looking at the Cartesian coordinate system, which is the foundation or planar or flat coordinate systems. Most of us recognize this from math class, an x-axis running left to right and a y-axis running up and down. Every point on the plane can be defined with a pair of values or coordinates written as x, y. This system works perfectly for flat surfaces and is the basis of how projected coordinate systems operate. Once we project the curved Earth onto a flat map, we can then assign locations using Cartesian coordinates, for example, in meters or feet instead of degrees. So in short, the Cartesian system is what allows geographic data to be managed, measured, and analyzed on a flat map, building on the projections we just talked about. Moving on, let's talk about the Universal Transverse Mercator System, or UTM. UTM divides the world into 60 zones, each one 6 degrees of longitude wide. Each zone is centered on a central meridian. For example, 120 degrees west would be the central meridian for one of the zones. One of the key strengths of UTM is it preserves direction and local shapes, making it a conformal projection. That's why it's so widely used for detailed mapping and navigation. The system covers most of the globe, extending from 84 degrees north to 80 degrees south. In practice, UTM coordinates are easy to recognize. The X value, called easting, is usually a 6-digit number, and the Y value, northing, is usually a 7-digit number, especially in the northern hemisphere at latitudes above 15 degrees. So UTM is a practical application of projections and Cartesian coordinates, giving us a grid-based system that can be used globally for precision mapping. This map here shows the full layout of the Universal Transverse Mercator or UTM zones across the world. As we mentioned earlier, the Earth is divided into 60 zones, each 6 degrees of longitude wide. You can see them here, numbered from west to east, starting at the international dateline. Each zone is also split into northern and southern hemispheres. For example, Zone 12 North covers parts of the western United States, while Zone 12 South would cover areas in South America at the same longitude. Looking at the map, you can see that much of the United States falls into zones 10 through 19. Europe is primarily covered by zones 28 through 35. Australia lies mostly within zones 49 through 56 in the southern hemisphere, and Africa stretches across a wide range from zone 29 in the west zone, 38 in the east zone. By combining the zone number with a hemisphere designation, UTM gives us a precise way to reference locations anywhere on the globe. This system is especially valuable because it causes the Cartesian grid approach we just looked at, making coordinates easy to measure and work within meters instead of degrees. So, why the Universal Transverse Mercator system so widely used? On a global map, UTM lines appear straight, which makes the system easy to work with. At this core, UTM is a type of projection designed to turn our round Earth into a flat, workable map while minimizing distortion with each zone. As we saw earlier, the Earth is divided into 60 zones, each 6 degrees wide. These zones are numbered from east to west and also lettered from north to south to distinguish between hemispheres. Another key feature of UTM is its measurement units. Instead of working in degrees, which can be abstract, UTM uses meters, making it very practical for surveying, navigation, and precise mapping. So to recap, UTM takes the concepts of projections, Cartesian grids, and coordinate systems and pulls them together into a comprehensive framework for identifying and measuring locations across most of the Earth. To conclude, let's bring everything together. We started by looking at geographic coordinate systems, which measures locations on the curved surface of the Earth using latitude and longitude. We then compared them to projected coordinate systems, which represent locations on a flat surface using units like meters or feet. Along the way, we explored how datums provide the reference model for the Earth's shape, how projections flatten the globe into a map, and how Cartesian coordinates allow us to assign precise locations on a flat grid. We then connected it all to the practical systems like UTM, which is widely used around the world. The key takeaway is this: The choice of datum, coordinate system, and projection matters. They're not interchangeable. Using the wrong one can cause mismatches between data sets, leading to errors in location, distance, and analysis. So, whenever we work with spatial data, choosing the correct reference system is absolutely crucial for accuracy, consistency, and effective mapping. Thank you all so much for your time and attention today. I hope this presentation gave you a clear understanding of how geographic and projected coordinate systems, datums, projections, and systems like the UTM all connect together to support accurate mapping and analysis. As you move forward in your work, remember that choosing the right coordinate system, datum, and projection is not just a technical detail, it's the foundation of reliable spatial data. All right. Let me go ahead.
Thank you, Ronnie.
You are very welcome.
Now, if you are feeling overwhelmed by that, do not panic. The spatial reference or spatial references and datum and how we map, there's a lot that goes into it. And there's a lot of options that we're going to look at here in a second. Those are the most common ones, but they are definitely not the only ones. Let me go ahead and pull up our training map, and we'll look at how ArcGIS Pro now, I don't want to say deals with, but works with datums and spatial references. So in our training map, we've been doing some basics. We have our little ranch with the watering system and the pastures while it's pulling up here. I went ahead and created another map for this training. You can see it's NAD 1983s on 12. So
You might have, there you go. We lost you for a second, Sarah.
Oh, sorry. Sorry. I was just saying, if you load something in there that does not match the same references, you're going to see a little warning up here that's like, hey, you might want to do something about that. But in order to check what you're currently mapping in, if you right click on your map, remember our little map icon, you go to properties, and then you can go to coordinate systems. This is where you can check, like, okay, this map is mapping using WGS 1984 Web Mercator. That's how it's doing it. And I can hit OK, and I'm going to go to this NAD 1983s on 12. And if I do this, this one is pulling in our NAD 1983 UTM zone 12 because 12 north, because that is what Arizona, well, I won't say all of Arizona, but I'm pretty sure most of Arizona at least sits in. So now to check our shape files, we can do the same thing. You right click on them, you go to properties, and you'll be able to set the source, I believe is where. Ooh, yep, it says it. So you'll hit source and then you'll hit spatial reference. That's why we've been calling them spatial references, because this one is using the projected coordinate system, WGS 1984 Web Mercator. Now, as we kind of heard from the presentation, there's pros and cons to all of them. I use WGS 1984 because it's what a lot of the web services that we use because it's global. However, a lot of the handheld Garmin GPSs, I believe, use NAD 1983, which is fine. I think it all just depends on where it's going to end up and just making sure you're keeping them consistent with the map that you're drawing. So if I wanted to put this shapefile into here, I can. I'm going to simply copy it and paste it over here, and ArcGIS is going to let me do that. It's probably not going to tell me anything about it because I've already uploaded this into here. But it's my job to make sure that I'm using the correct data reference for what's there. So if I go and right click on this and come to properties just to make sure and kind of show it did not change. It's still using WGS 1984, which is okay. And I need this down here. Ooh. Okay. So the way to transpose it is going to go into analysis. So analysis is kind of where we do, you know, our big map type of changes, not our individual layer changes necessarily. Ooh. Woo. Let me go back in there. Oh, sorry. Hold on. All right. And if I come down and I hit this project, you see, I love how we can highlight over it and it'll tell us what's going on. But this is how we can change how it's being projected. Sorry. So I'm going to go ahead and put the input class. And again, we can use the little eyes to make sure we're doing it correctly. But this should be the feature that I want to change. So it wants to be my point. I'd like to change the name of it to point NAD. I'm going to do 83 NAD. And then the output coordinate system, I want to be the current map because that one's different. So you can see here, ArcGIS does a great job of kind of helping us out. And it says, oh, okay, so you want to take WGS 1984, which is the coordinate system my layer's in, to NAD 1983. Yes, I do. And so I just get to hit run and it's going to go ahead and do that. And it's going to change it for me. Now in this here, what's drawing, there's not really a huge change. However, in experience, depending on which coordinate system it is, it could be quite a big jump. Like I've had them throw me almost 3/4 of a mile south of where my actual markers are with some of the older datums. So I can double check that it did it. I can come to properties, go to source, make sure that now we're looking at the correct thing, and we are, and now everything matches. So it should be drawing as accurately as possible. I do want to show you, go to properties here. There's a lot of geographic coordinate systems and projected coordinate systems within ArcGIS. So just kind of paying attention to which one you're using can be really important. And I just want to show you some of them. I'm trying to get it to open all the way up. Even in World, there's a lot of options. That's just one of the many drop downs. So it can go between quite a bit if you do get thrown a weird coordinate system. Does anyone have any questions on that?
You guys can unmute if you want. Up at the top, you can raise your hand or you can even type in the chat. Don't be afraid.
Okay, it's okay if not.
Okay.
So the next thing that I wanted to show you is kind of working with elevations and measuring with elevations in ArcPro. Now, we've been dealing a lot with layers and we haven't talked about rasters yet. But rasters are another type of drawing system, if you will. And it's what we use for elevations a lot of times. And if you need a raster, so in order to measure with elevations, you need a raster data set that has elevations of the world in it. So USGS is a great free online source that you can pull this information from. And I'm pulling right now their elevation products. However, they have a lot of free products available. They're a really good resource if you're looking for something kind of specific for mapping or with, they have a lot of info in here. But anyway, so I'm gonna go ahead and show you. So Arizona does not have full LiDAR data yet, but it's working on it and it's all available here. These are DEMs though, and I'm gonna show you this 1 meter. So rasters are made up of like little squares
Sarah,
everywhere.
real quick, can I
Mhm.
interrupt you? We have a
Yeah.
question. Why does the UTM coordinates show 12S on the garments for Arizona? I tried changing it to 12 North, but received errors in the past.
It's probably using, I would check the coordinate system it's actually using. It's probably pulling from one of the other ones. It's not probably not wrong because it's a GPS tracking you, but it's probably using a different coordinate system than the one that I showed that was NAD 83 North. It might be one of the other, either geographic or something like that is happening. Sorry that I don't have more info though. Without seeing it, I can't tell you. If you want to though too, I can set up a meeting with you and that might be a good training video we could help with if it's a common issue.
He said it's NAD 83.
Yes, so there's a lot. So if I pull this, or let me show you. So there's a bunch of them, is why I say it's probably one of the other ones. So if I go here and go to, actually, let me just search. So there's a bunch of NAD 83s. So it could be one of these other ones with kind of a special modifier on it that's pulling it. It could be, um, there's also others in the projected, like instead of being, it could not be like, that's what I mean. There's quite a few of them that it could be pulling from, if that makes sense. So see if it has any other qualifiers behind it. So I'm pulling from the UTM zone 12 north. I could pull from the UTM zone 12 south though to match that.
Good.
That I hope that helps. I know there are a lot.
And we can also touch base after and send an email.
Yeah,
And if you need help kind of moving forward with that, Sarah can meet with you one-on-one.
most definitely. So, rasters. So they're little squares all over. So this 1 meter means that these are 1 by 1 meter by 1 meter tiny squares all throughout. And this is where we have that kind of information for it. So you can see Arizona isn't quite to 1 meter scale yet. A lot of this lines up with what type of LiDAR data is available or not to USGS. However, one that we do have is 1/3 arc second DEM, and these ones should be about 10 meter by 10 meter. So I just want to mention that because it's important to keep in that there still may be some air, as you can imagine. In some of these canyons, 10 meters could change a lot. So if you select this though, and then you can actually put in a point or an area and be able to search products, and then you can download a raster data set to use in ArcGIS. When you pull that in, I'm going to go back to my main map. I'm going to add this raster so you can see it, but you don't necessarily have to add it to use it for your elevation. So it's going to load as a TIFF file. You see it says raster data set. I'm going to hit OK. And it's probably going to take it just a second to fully come in because these are quite large data sets. There it goes. Let me zoom out so you guys can kind of see it. So this is how it'll automatically load in. You may get a question if you want to calculate statistics for the raster. I always say yes, because it'll let you get a little bit more features with it than if you do not. But you can see like this is going to be a wash. As you get darker, it gets lower. And as it gets lighter, we're getting more towards the top of the mountains and things. So all these darks dark spaces are probably washes or valleys, or probably washes in this area. Yeah. So I pulled it in so you guys could see what they look like, but you don't have to have them be your elevation information. If you just go to map and hit add data, and then you can tell ArcGIS to do your elevation source layer and navigate to it again and hit OK. It's going to go ahead and pop up this elevation surfaces, ground, and pull in that raster data set. The next thing to do, oh, hold on, let me move my part. If we come to, we go to our analysis, believe, maybe not. There it is. So analysis again, and then our exploratory 3D analysis, and hit that drop down. Now that we have an elevation source, we get these two new options, and one of those is creating an elevation profile. So I'm going to go ahead and select that and zoom back into our line. So in here, you can select feet. You can do an interactive placement. That just means that you draw. So for instance, if I wanted to know what it looked like on this fence line, I could do that. And as you can see, it pulls up this elevation profile that you can then move along both on your map and on ArcGIS Pro. It gives us the total distance of this line with elevation accounted for and the elevation differences between it. And because I have feet selected, it's doing it all in feet. And it is always good to double check with actual topo lines from a map to make sure it's calculating correctly, just to double check that it somewhere in that metadata, it didn't get transferred between meters and feet incorrectly. And so I have gone ahead and checked that with this. Yeah, and then the other way you could do it is if you do have a line, you can select along a line, and I'm only have one line layer available. So that's my line. Let me go ahead and exit out of this. It should. Ooh. It should let me do that. I'm not exactly sure why it's not, but you can do the interactive and be able to put your snapping feature on and still snap to your line. And get that. Yeah, any questions? Oh, I think I figured out. Well, I'll play with that a little bit more and it'll be in our info sheet. It was working earlier, so I'm not sure why it's not right now. But any questions about getting that elevation kind of information? It gives you the measurements right there with it, or pulling elevation data.
Looks like you're good so far, Sarah.
Great. Well then, if we didn't blow your mind too much, that's really the big things that I wanted to cover. I knew that spatial references would be kind of a lot to wrap our heads around. So yeah, we can let you guys go a little bit early unless there's any other questions about anything else that is not related to things we've talked about.
I had one of our attendees who made a good point in the chat about the 12 North and the 12 South as well. If you guys wanted to check that out, he went ahead and included a link too as to why why there was confusion with that. And I also feel like I might be having one more question coming in as well. So hold on one second.
Thank you who tossed it in there. That was a
And I know too, we did have a feedback response from someone that who I don't know if you want to dive into it now or go into it at a different session on how to have a layout show two maps.
yeah. I can dive into it since it's good timing. So I think we've talked about, so this was one of our old layouts that had, so we're using the same map. So if you click on these layouts and go to your properties, you'll be able to see this map frame. Sorry, that was a right click and then to properties. And then you'll be able to see this map frame under options. And so you can actually select which map frame that is going to pull from. So for instance, if I did our NAD one that was a little bit bare, it pulls from the other map. So this is what this one looks like right now, and this one, and that's how they're looking in there. And so you can have different layers and things like that tied to that, and you can do this for a lot of the features within your layout, even your legend and some of your other stuff based off of what you want it to actually pull from for scale or symbology.
Great, thank you. And then we had another attendee go ahead and put in the chat too for a link on how to download raster data.
Ah, perfect.
So that is in there as well.
Nice.
Any of you guys have any other questions or something that you might want Sarah to kind of just touch on real quick for you before we kind of wrap up this session? Mm-hmm. Sarah, you got anything else to add?
I don't. Those are
Mhm.
kind of
Main
it,
points.
other than this elevation profile is pretty fun once you do have it all in there.
Well, all right, you guys. Just want to thank you guys. I hope you guys were able to take away some valuable insights and practical knowledge today. Your feedback is essential in helping us refine these trainings to better serve your needs. So when you have a moment, if you guys could check your emails, take a couple of minutes, complete the feedback form for today's session, and then your input will ensure that future trainings are even more targeted and kind of beneficial to your exact needs that you need. Keep an eye out for the registration link for our next session. I believe it's going to be projected for Friday, October 3rd at 8 a.m. And then, yeah, thank you guys for your participation. Again, these will be uploaded to the AACD website. The previous trainings are there. That link is in the chat for you in the beginning, and you can access those. And then in the next couple weeks, I'll be uploading this video as well. And then if you guys look in the description, there's going to be a reference sheet that I put together for each video, and it kind of gives a breakdown in a PDF format, and it goes in order of the videos, and it also kind of adds a little bit more kind of detail to what Sarah dives into as well. So, and then if you guys ever need any questions or need any questions answered or need help along the way until next month, just go ahead. You can email me. My email's in the beginning as well. And if I can help you, I will. And if not, I will connect you with Sarah. So thank you guys so much. Hope you guys have a wonderful rest of your day.